Alright, in this video we're going to look at the computational aspects of working out partial fractions. We're going to focus on the case of linear distinct factors. The principles, rules of setting up fractions we have done in a video entitled Partial Fractions 1. So if you haven't looked at that one, you might want to look at it. Here is the outline of what was discussed there in detail. So if the fraction is improper, we first divide it, and then we resolve into partial fractions the remainder bit. Otherwise, if it's proper, we factorize the denominator and we set up the partial fractions accordingly. For distinct linear factors, we said that each factor is going to have a corresponding partial fraction. So each factor is going to have corresponding partial fraction. Now, so here is an example here, resolve into partial fractions. 17 minus x over x squared plus x minus 12. Now you're going to notice that the degree of the numerator is 1 while the degree of the denominator is 2. So this rational expression is proper, so we don't need to do this step. So we're going to go straight away and factorize the denominator. So here the denominator is going to factorize into x plus 4 times x minus 3. We do have another video of how to factorize quadratics, just in case you are not up to speed with that. So for each of these linear factors, we are going to have a corresponding partial fraction. So a over x plus 4 plus b over x minus 3. So the focus of today's video is how do we find these two constants a and b. So the first thing we need to do here is to multiply everything by the denominator. Okay, at this point, multiply everything by the denominator. So we're going to multiply everything by this term here. So let me just do it step by step for this example, and then for the next examples we can go through it quickly. So we've got 17 minus x all over x plus 4 into x minus 3 is equal to a over x plus 4 plus b over x minus 3. Now then we multiply everything by the denominator. So like here we're going to multiply by x plus 4 x minus 3. We're going to multiply this one by x plus 4 into x minus 3. We're going to multiply this one x plus 4 into x minus 3. Then what's going to happen, this side, this will cancel out with that, so we remain with just the numerator 17 minus x. For the first term on the right hand side, the x plus 4 will cancel out. For the second term, the x plus minus 3 is going to cancel out. So on the right hand side we're going to end up with a into x minus 3 plus b into x plus 4. This is going to be an important equation. Let's name it equation asterisk. Okay, So you're going to notice what has happened here is some kind of cross multiplication where this term is now multiplying a and this term is now multiplying b, and the denominator here has disappeared. So basically this step has just cleared all the fractions. Now at this point there is two ways we can proceed. The first method is where we are going to compare coefficients of the polynomials on both sides. Compare coefficients. So you can see this side we have a polynomial, also this side we have a polynomial. It's just that this side the polynomial involves these unknown numbers, but the mission of this is to find those numbers. So what we're going to do is we're going to remove these brackets and then compare degrees of x. So on the left hand side we're just going to have that 17 minus x. If we remove brackets, we're going to have ax minus 3a plus bx plus 4b. Then we are going to rearrange this in terms of terms of powers of x. So like we've got ax and bx here, so we're going to group that into a plus b times x. Then the constant terms are going to be 4b minus 3a, so that's these two here. Now these two sides must be equal. They are equal. So if they're equal, then the coefficient of x this side must be equal to the coefficient of x this side. The constant this side, sorry, 3a here, constant this side must be equal to the constant that side. So that is what is going to give us two equations. So if we start with the coefficient of x, for instance, on the right hand side coefficient of x is a plus b. On the left hand side it's -1. Then the constant on the left hand side, so that's the coefficient of x to the power 0, it's -3a plus 4b. On the right hand side the constant is 17. So we now have two equations, two unknowns, linear. So we know how to solve this. If we multiply this by 3, then we're going to have 3a plus 3b is equal to -3. If we just write this one as it is, -3a plus 4b is equals to 17. Then we add, so a is going to drop out. We're going to have 7b is equal to 14. So what this thing is telling us is that b is equal to 2. Then if we substitute it here, it's telling us that a is going to be -3. So this is the one method, comparing the coefficients of the polynomials. Then there is method 2. Okay, method 2. I'm just going to rewrite this equation asterisk. So method 2 says substitute any two values of x in equation asterisk. So there is our equation asterisk. Just going to rewrite it here again. So we have got a into x minus 3 plus b into x plus 4. Okay, so the idea is this. This equation here is true for any value of x. Okay, so the two sides, it doesn't matter which value of x you choose, these two sides are going to be equal. So we've got two unknowns. Okay, so that's why we need two values. So if we had three unknowns, then this would be 3. So since we've got two unknowns, we need two equations. So we can just plug in any values of x, any two values, and then have two equations in and b, and then solve them. Okay, so that's so let's just do that. So let's try x equals to 0 first. If x equals to 0, the left hand side is going to be 17. The right hand side is going to be minus 3a plus 4b, because there's going to be 0 there and 0 there. And notice this is exactly the same as the second equation that we had in that first method. Then secondly, we can try any other value of x. We can make this as complicated or as easy as we want. Let's try x equals to 1. When x equals to 1, there's going to be 17 minus 1, so it's going to be 16. This is going to be 1 minus 3, so it's going to be minus 2a. This is going to be 1 plus 4, it's going to be 5b. Okay, now this time if we multiply the first equation by 2 and then multiply the second equation by 3, then these two will match up. So multiply this one by 2, going to have 34 is equal to negative 6a plus 8b, and then multiply this one by 3. So basically we just do cross multiplication of these two numbers. So if we multiply this one by 3, we are going to have here 48. This is going to be minus 6a plus 15b. Then if we subtract this time, okay, then the a's are going to cancel out. So if we subtract the first one from the second one, 48 minus 34 is going to give us 14. 8 drops off. 15 minus 8 is 7. So again we've got 7b is equal to 14. So b is equal to 2, and then we can continue as usual. Okay, so that is the second method. But just notice what's going to happen here if we try x equals to 3 and x equals to 4. Okay, so notice what happens with x equals to 3 and x equals to negative 4. So we're plugging those ones here. Okay, so let's start with x equals to 3, for instance. So when x equals to 3, the left hand side is going to be 17 minus 3. 17 minus 3 is 14, so it's going to be 14 there. The first term here, this is going to be 3 minus 3. So 3 minus 3 is 0. Then the second term is going to be b times 3 plus 4. 3 plus 4 is 7. Now from here you can see that a is going to disappear, so this is just 7b is equal to 14, and so b is equals to 2 straight away. Then if we do x is -4, the left hand side is going to be 17 minus -4. So 17 minus -4 is 21. Then a here we're going to have -3 minus 4. Just write it out. -3 minus 4. Then for b, we're going to have b times 4 minus 4 is going to be 0. So this time b cancels out. So this thing is saying 21 is equal to -7a. And so a is -3. So if we use x equals to 3 and x equals to -4 and just 2 lines, we find the value of a and b. Then the question is, well, what is so special with x is equals to 3 and x equals to 4? And the answer is x equals to 3 and x equals to 4 are the roots or the zeros of this denominator. Okay, so the thing that we're going to come up with here is, or the conclusion is that we are always going to want to use these roots, because then we get to the solution pretty quickly. So these are the roots of the denominator. So of course roots and zeros are the same. So that's what we're going to do. But for this example, we now can write it in partial fraction form. So 17 over minus x over x squared plus x minus 12 is going to be a is b is 2, so let's start with the positive one. It's going to be 2 over x minus 3, and then it's going to be minus so minus 3 over x plus 4. So I've just plugged those into this starting expression there. Okay, so now so those were the two methods. In the next example, we will not necessarily do both of them. Actually, we prefer the second method, using the roots, because that's going to work out pretty quickly. Okay, one more example, and then we will give you something that you can try yourself. So in example B, suppose we have 4x cubed plus 3 divided by 2x squared minus x. Now looking at this, we notice that the numerator is degree 3, the denominator is degree 2. So this rational expression is improper. What that means is that we need to divide first according to the guidelines that we set up here. So we're going to divide this using long division. So 2x squared minus x here, and so 4x cubed So when we are dividing, we need to make sure that all the powers of x are represented. So we're going to write 0x squared here, 0x, then of course plus 3 is there. Okay, then 2x squared into 4x cubed goes 2x times, then 2x times 2x squared is 4x cubed. This is going to be minus 2x squared, and then we subtract. This is going to be 2x squared. We bring down 0x, and 2x squared into 2x squared goes once, so it's going to be 2x squared minus x. Then we bring down, that's going to be x, we bring down 3. Since the degree of this is now lower than the degree of that, that means this is our remainder. So 4x cubed plus 3 divided by 2x squared minus x is equal to 2x plus 1. That's the quotient here. Then the remainder is x plus 3, then over 2x squared minus x. This is where our attention is now going to focus. So I'm now going to resolve this into partial fractions. Okay, because this is now a proper rational expression. So first thing we're going to do is to factorize there, which shouldn't be too difficult. So we are going to have x plus 3 over x into 2x minus 1. So the partial fractions are going to be a over x plus b over 2x minus 1, because these are linear factors. Then if you multiply through by the denominator, this denominator here, the left hand side will be x plus 3. Here we're going to have that cross multiplication thing. This multiplies that and that multiplies that. So we're going to have a into 2x minus 1 plus b times x. Then we are going to do two values. We're going to use the roots of this denominator here. And the root corresponding to this factor is 0. The root corresponding to this factor is going to be 1/2. We just take each of these and equate them to 0 and solve. So we're going to plug in x equals to 0 first. Left hand side is going to be 3. The right hand side is going to be negative a. This term is going to disappear. So this is simply telling us that a is negative 3. Then we're going to use the other one, x equals to 1/2, which you get by taking 2x minus 1 and equating it to 0. So when x equals to 1/2, this is going to be 1/2 plus 3, which is 3.5, 7 over 2. This term is going to disappear. This one is going to be b times 1/2. So from there we see that b is going to be 7. So that means this is going to be 7 here. This is going to be negative 3. So finally, so 4x cubed plus 3 over 2x squared minus x is going to be equal to, so remember, first we have got the 2x plus 1 2x plus 1, and then plus, then the proper part, this one, is equal to this. So we're going to have minus 3 over x plus 7 over 2x minus 1, and that completes that one. Okay, all right, let's just give you one to have a go at. So what you can do is to pause the video, have a go at this, and then when you continue the video, you will find our answer on the in the rest of the video. Okay, so if you just want to have a go at this and see if you are actually understanding the ideas. Okay, we take it that you have had a go at this example number C. I'm now going to scroll down to our solution. If you still want to, you can still pause the video and try it first. Okay, so in example number C, the degree of the numerator is 3 and the degree of the denominator is 2. So this is improper, so we're going to have to divide first. We use long division. Again, if you are not up to speed with long division, you can check our video on long division of polynomials. So x squared goes into x cubed x times, and then multiply x into this, we get this, we subtract, it's going to give us x squared plus 3x, and then we bring down 0, and then x squared into x squared goes once, multiply 1 into this, and then we get that, then we subtract, that's going to give us 4x plus 2. This is now smaller, lower degree than this one, and this is now the remainder. So we can write our rational expression like that. That's the remainder there, and that's the quotient. So that means we now need to focus on this bit, which is proper, and resolve it into partial fractions. So that's what we do here. So start by factorizing the denominator. Then these are going to be our partial fractions, and then upon multiplying everything by this, we clear the fractions, so that multiplies that and that multiplies that. The two roots of these are 2 and negative 1. I plug in x is 2 here, we get a is 8 over 3. When I plug in x is negative 1, get b is 2/3. So that means this we can write like that, and finally it looks like that. Okay.